Today we're going to talk about the vertex form of a quadratic. So we've been doing most of our work with this quadratic form, which is sometimes referred to as standard form or polynomial form. Today we're going to take a look at vertex form. Whoops. Spell that correctly, vertex form, which is convenient because this H and K represent the coordinates of our vertex. So let's start off with something like x squared plus 6x minus 1. This is in polynomial form. We're going to write this in vertex form, and what we do is we group the x's and then we're going to complete the square within the parentheses. So within the parentheses we want to find b over 2 squared. B is 6. That's 3 squared, which is 9. So we're going to add 9 within the parentheses. But we just can't add, we can't just add 9. We'd have to either add it to the other side of the equation, but we don't really want that because we do want y equals here. So instead of adding to both sides, we're going to add and then subtract from the same side. So that way we're really just adding 0. We factor what's in the parentheses. This is a perfect square, x plus 3 squared minus 10. There's our vertex form, and the coordinates of our vertex would then be -3, -10. Sometimes we have a coefficient. This a value right here, which would be equal to a in polynomial form. So let's look at an example. Let's try 2x squared minus 8x plus 5. Again, we'll group the x's, but before we complete the square, we want to factor out that 2. Then we find b over 2 squared. B now is 4. We get 2 squared, which is 4, so we'll add 4 here. But on the other side, we're not going to just subtract 4, because we added really 4 in these parentheses. This is 4 times 2. So now we subtract 4 times 2. So y equals 2 still on the outside. This factors as x minus 2 squared. Then we've got plus 5 minus 8, which is -3. So our vertex is 2, -3.